the phase one is completed, you then proceed further to understand the various data types. Data types are very critical, right? Post that, we proceed further with data collection. Within data collection, we have primary data collection and secondary data collection. We first need to proceed further with secondary data sources. And once we are happy with the secondary data sources, if you're happy with the amount of data that you have, proceed further. If you're not happy, if you feel that certain variables, certain data points are missing, then you proceed further with primary data collection mechanism. And then we have phase two, which is data preparation. Within data preparation, we have exploratory data analysis, descriptive statistics. While you do that, at the same time, we also perform data cleansing, pre-processing, munging, wrangling, organizing, etc. And also feature engineering. Okay, feature engineering includes a lot of steps such as feature transformation, feature shrinking, scaling, and that way there are a lot of options within feature engineering. Once data preparation is done, you proceed further with model building. Within model building, we have unsupervised learning, which is also called as descriptive modeling. We have supervised learning, which is also called as predictive modeling. And then we have forecasting time series. And once you build the model, you evaluate. When we get into evaluation phase, you don't just evaluate the machine learning success criteria. We also are expected to evaluate business and economic success criteria as well. Okay, then you go and deploy a model in production. After you deploy a model in production, you need to continuously monitor and maintain the project. Now, just quickly allow me a minute because I need to show you the end-to-end deployment, and that is what I've promised. Just allow me a quick minute. Yep, so extremely sorry about that. All right. So I would also towards the end show you how to deploy artificial neural network model on production environment. Right? But we will make use of only Python Flask to do that. Now, when I go to mind map, which is artificial intelligence and deep learning, we have deep learning primer. Within deep learning primer, you have human brain, which has neurons, which are basic unit of information processing. And then we have compositionality. Okay. Then we have input layer. We have hidden layers. and then you have output. Number of hidden layers is empirical. Means you decide on how many hidden layers you want. Number of neurons in each hidden layer is also empirical. In one hidden layer, you might have 4, in another, you might have 3, so on and so forth. Okay. So you have the initial hidden layer, which will capture the low level details. Then you have the next hidden layer, which captures the mid-level features. Then we have the final hidden layer, which captures the high-level details. And finally, you have the output. In every hidden layer, you will have integration component and activation components. The number of hidden layers that we are going to have in the input layer will be fixed. The number of hidden layers or the number of neurons that you will have in the input layer will be fixed. The number of neurons that you're going to have in your output layer would also more or less be fixed. So the only thing that you need to worry about is number of hidden layers and number of neurons in each of the hidden layers. Also, what should be the activation function? Okay, what is the activation function that we want? Is something which is again hyperparameter. You need to decide number of epochs, number of iterations. What should be the loss function or cost function? All of these would be hyperparameters. And what should be the optimization function, optimization algorithm? All these are the hyperparameters. Okay, so having said that, there are certain thumb rules when it comes to activation functions. What are those thumb rules? If the output variable is continuous, okay, then if the output variable is continuous, then you have linear function or identity function. If the output variable is categorical, and if you have two categories, binary, two classes or two categories, then the output neuron, in output layer, you'll have a neuron. Within that, activation function can be sigmoid function or tanh. And let me direct to this. This can be directed to linear function or identity function. And then when you have output variable, which is categorical, and if you have more than two classes, then you proceed further with softmax. Okay, softmax activation function. Having said that, when you deal with images, convolution neural network, right? When we use convolutional neural network, then In the hidden layers or in the convolutional layers, usually the activation functions which are used are ReLU functions. Either you use ReLU or leaky ReLU or some variant of ReLU. And when people have experimented with that, it started giving amazing results. Hence, people use this. Then we also have optimization algorithms. When it comes to optimization algorithms, we discussed about batch gradient descent, stochastic gradient descent, mini batch stochastic gradient descent. And there are various other variants which will help resolve the issues which we have in mini batch SGD. And we also discussed that when it comes to mini batch SGD, you need to provide something called as a batch size. And then we have practically looked at Python programming. We also had an overview of math foundations. We also discussed about, what are the various regularization techniques and how do we fix those. Okay. So now we need to look into the last variant because today happens to be the last day, which is recurrent neural network. When you have structured data, which is either tabular or columnar, then we proceed further with artificial neural network or multi-layered perceptron or dense network or fully connected network. And when we have unstructured data, we have videos, you'll have images, then you have audio files, and then you have textual data. When you have videos or images to deal with, we use CNN, convolutional neural network. Whereas when we have textual data to deal with, we have recurrent neural network. Okay, next. So we have artificial neural network, which we have already discussed. We have already discussed about convolutional neural network. Now we are talking about textual data. But the good part is recurrent neural network will work whenever you have sequence in the data. Sequence need not just be sequence of words as in textual data. Sequence can be sequence of numbers also. It can be sequence of speech, audio also. Of course, audio will eventually translate into textual data only. So here, if I were to explain you one quick thing, videos would eventually become images because videos are broken down into multiple images. And your audio files are always broken down into textual data. Okay, then. We are talking about sequences. You have sequence of words. When it comes to textual data, we'll have sequence of words. If you have sound, you have sequence of sound. I mean, I'm speaking, sequence of sound is coming out, but speech is in some sense going to be textual data only. Because when I speak, what am I speaking? I'm speaking words. Next. your, you can also use this for, which is recurrent neural network, right? I'm talking about recurrent neural network. That can be used for machine translation. If you have something which is written in German language, and if you want, you can convert that into English language also. So you have this in German language, you're converting that into English language. And here, the sequence in which the German words are used and the sequence in which you're getting the English is not the same. They're different. Third word happens to be first word. So what does that mean? First, the entire sentence should be processed. Entire sentence should be processed. And then you get the output. So we have to ensure that the entire sentence is processed in order to get the output. All right. Now, your traditional language models cannot process the entire sentence and store them in memory. So this entire sentence has to be processed in, and then you have to translate that into another language. It's called as machine translation or language translation. Until and unless you store all these words in memory, you cannot really say that the first word of English language is actually the third word of German language. You cannot establish that correlation if you cannot store all the words which are processed in memory. You need to store them in memory, actually. Okay. So we have the traditional language models. And here, you have probability of different words. And traditional language models are used to solve a lot of amazing business problems, such as next word prediction. If there is a sentence which says, stocks plunged this morning, despite a cut in interest rates by the Federal Reserve. As well, what do you think can be the next word? What do you think should be the next word? Obviously, it will be street. Then spell checkers. If you are typing and if you observe an incorrect spelling, okay, you might have to rectify that, and automatically it happens, right? Automatically spelling mistakes are identified and then you can rectify this. And when you're sending a message, your mobile would auto correct certain words. So fine actually will become find. Automatically it happens. Then if say someone is speaking over a phone, and if this comes out, that theater owners say popcorn or unicorn sales have doubled. Okay. If by mistake, if the theater owner or if the voice is not clear, and if it reads as unicorn, if your speech recognition system or speech to text, when you're translating, even if the voice wasn't clear and if it identifies you as unicorn, it is automatically corrected to popcorn. Then we also have automated essay grading. When you write, in a lot of competitive exams, we have people writing essays, right? In IELTS, there'll be written exam. In GMAT also, you'll have to write. Right? Those things usually are evaluated by people, humans, professors. But what if that part can be automated? Then it's called as automated essay grading. And then we also have machine translation. So word ordering, probability of words appearing in this sequence, the cat is small, the probability of words appearing in that sequence is the probability is always greater than the words appearing in a different sequence. Small, the, is, cat, right? So the sequence is very important. Then you have word choice. In word choice, you have this. The probability of walking home after school, the words appearing in this sequence will have a higher probability as opposed to using house, right? Home, the usage of word home, the choice of word home has more probability as opposed to having the word house. Okay, next. When it comes to the traditional language models, you'll have a lot of words. Each individual word that we have, different words, are called as unigram words. Unigram means single word. And within English language, the vocabulary size, if I say that English number of words is equal to V, vocabulary size, there are approximately 172,000 words. Okay. In English vocabulary, you have 172,000 words overall. So the number of unigrams will be equivalent to 172,000. And then we also have a bigram model. Bigram means two words. And the way it is calculated is using a probability score, right? For example, what is the probability that we'll have the word language given that traditional already occurred? So this is word one, this is word two. What is the probability that we have language given that the word traditional has already occurred? This will give you count how many times you have word one and two divided by word one. This is bigram model. And then we also have a trigram model. What do you mean by trigram model? Three words. For a bigram model, how many words will we have? If you have V words in English dictionary, then for a bigram, you'll have V square words, approximately. And if it's a trigram model, you'll have V raised to the power 3. So 172,000 into 172,000 into 172,000. Those words will be humongous. And how is it calculated? Probability, suppose is word 3. What is the probability that the word models will appear given that the word traditional and the word language have already appeared? Okay, given that these two words have appeared, what is the probability that you'll have word 3? So you count number of times word 1, 2, and 3 appears divided by total number of times word 1 and 2 appears. But the challenge with the traditional language model is that as and how the number of words increase, number of grams increase from unigram to bigram to trigram to 4 grams, if you keep on increasing, you'll run out of memory. To take huge amount of time. And people in 2013 have experimented and they've used a machine with 140 GB RAM. 140 GB RAM is even today considered to be very high configuration. And they have used it for 2.8 days. And when they've run this machine for 2.8 days, ultimately 126 billion tokens were generated. 126 billion tokens were generated. Okay, then. Suppose that's one drawback. Okay, from traditional language models, what is the drawback? Availability of memory. If you have n grams, then the vocabulary size will be v raised to the power n. That will just blow out of proportion. Even today, we don't have that powerful machine, right? Though there are a lot of models which are being built with trillion parameters and all that, it's going to be very, very costly after. This is one drawback, okay, wherein you might run out of memory. You will have memory issues when you use traditional language models. And another drawback is that storing the words in memory. For example, say you're reading some book, history book. Say in that history book, it is written that Spain and France went on a war. Spain and France went on a war. And somewhere in the subsequent sentence, if it is written as the two countries, then here the two countries refer to Spain and France. So you have Spain and France, which refer to the two countries. But then, until and unless the information in the first paragraph is captured, in the subsequent paragraphs, the moment the two countries is seen, you will not be able to correlate that the two countries are Spain and France. But traditional language models have no functionality to capture the information and save in memory. So that means you cannot store in memory. Memory storage of past words. Then you might say that, okay, why can't we in that case use a multi-layered perceptron model only? Why can't I use this MLP? Might be a question. Yes, you have a valid question. Suppose you created a data set like this, wherein you built a model with 3 words. You have 3 words, which are like 3 inputs, x1, x2, x3. And say you want to predict the 4th word. Sentence 1, 2, 3, 4 in that way. When you build a model here, each and every word that you have, you cannot supply these words as is to your algorithm. You cannot do that. Each and every word cannot be supplied as is. So what you do is you convert the word into a one-hot encoding format. So each word would be converted into a one-hot encoded format. How is it converted? How many words do we have in English dictionary? Approximately 172,000. Okay, approximately 172,000 is what you have. So a, and, in that way, say you have all the 172,000 words. assume. There is word one, right? Whichever is that word. For example, original is that word, assume. So everywhere you'll have zeros. Wherever you have this word original, you'll put a one. Then you have the next word, which is neural. So you keep on looking at, next word, wherever you find neural, put a one, rest all will be zeros. Same is the case with the language also. Wherever you have language, put a one. In the rest of the places, put zero. And then if the fourth word is model, that is something that has to be predicted. But of course, that also should be one converted into one hot encoding. That means for each and every word, you will have the size of this will be equivalent to V. For this word 2 also, the size will be V. For word 3 also, the size will be V. V means 172,000. And then you connect all of those to a hidden layer. Suppose in the input layer, you have, say, 3 neurons. And then you have one hidden layer. Or 2 hidden layers, just for the example. In this case, you have 1, 2, 3, 4, 5, 6. 3 into 2, 6. Excluding the bias variable, you have 3 into 2, 6 weights. If you have V here and H here, then how many weights will you have? VH. VH will be the number of weights. Okay, and if you have n number of words, for example, if you have n instead of 3, if you have n words, then this will become n into VH. So those many weights will be there here. In the final layer, you'll have the size of the vocabulary. Means if you have 172,000 words in English, you'll have 172,000 neurons. And every neuron would give you an output, which will be the probability value. Okay, every neuron will give you the probability value as output. And you will take that word which has the highest probability. And the number of weights here will be equivalent to VH. Okay, so here we have NVH, here we have VH. So in total, we have NVH plus VH. So this will be nothing but N plus 1 into VH. These are the number of weights. Okay. So the number of weights when it comes to MLP, let me write it down here. When you deal with MLP or ANN, the number of weights will be N plus 1 into VH. Here you have v raised to the power n. Here you have n plus 1 into vh. Then we also have, I mean, of course, there is another problem. Memory issues, it is much better, right? Here you have v raised to the power n, means 172,000 raised to the power, say, 5, 6, whatever. And here, the number of bits will be very less in comparison to this. Okay, this issue is fixed. Wonderful. But there is yet another problem. That is, if you train your MLP, how about storing the previous words in memory? In first paragraph, if you have Spain and France went on a war, say in the 10th paragraph, it says the two countries. Now this two has to be related to Spain and France. That opportunity, that option doesn't exist. Okay, that option doesn't exist. So here we still are going to have the memory issues. This will be there still when it comes to MLP. These issues will be there. Memory storage of passwords. Okay, then how do we solve it is a question. And another problem is fixed window of context, meaning if you build a model in such a way that you have, say, 3 words, word 1, word 2, word 3, and say you want to predict the 4th word. So you have 3 words which are inputs and the 4th word is output. In this case, it will work only on this setting. If you have 2 words and if you want to predict the 3rd word, it doesn't work. If you have 4 words and if you want to predict the 5th word, it doesn't work. Why? Because you train only on this setting. So your model will work only for this setting. It will not work for any other setting as such. Hence, what you are expected to do is come up with a new algorithm, new neural network architecture, which solves these problems. So I'll also write down another problem is fixed window. Is yet another problem. Okay. Fixed window and not storing the previous words in memory are the 2 problems which MLP has. So we need to fix these issues now. To fix these issues, we have something called as recurrent neural networks. And how this recurrent neural network fixes all these issues. Let me explain. Okay. I will erase a few things like this issue. These issues are fixed and these issues also are fixed. But then let me ensure that these 2 remain. V raised to the power n is for traditional language models. So when you have traditional language models, V raised to the power n is a memory. When you have MLP, it is n plus 1 into VH. MLP, it is n plus 1 into VH. This is the amount of memory it consumes. Now let's look at recurrent neural network or RNN network. When it comes to RNN, say you have a data set. You can take any English literature, Wikipedia or whatever, and That's how people take the data. Okay? And you can have variable size here, variable size inputs. One sentence can be of different size, another sentence can be of different size. You can have in that way data. So if you take this word, you need to convert that into a one hot encoded format. And if you have 172,000 words, right, you're going to have 172,000 neurons. Yes. So this particular word, you do a one hot encoding. Okay. And then you convert this word into numbers, one hot encoded numbers, right? And in English dictionary, you will have 172,000 words. So let me call it as V. Because all the 172,000 words you put, and everywhere it will be zero, wherever this particular word exists, you put a one. Then you have the next word. Again, you take 172,000 words, everywhere put zero, in one place put one. The size of that also says V. Take the next word. Take all the 172,000 words, wherever you have that word, put one, rest all will be zeros. So that's also another vocabulary. Okay, so you have multiple words. I mean, if you have three words, three V's will be there. And say you have a hidden layer, let me call it as H. Forget about these for now. And this hidden layer H, this hidden layer H, etc. And the recurrent neural network is initiated using a dummy hidden layer. The first hidden layer will be dummy, all zeros, dummy hidden layer. Now, when you have vocabulary size V and your hidden layer H, so what will happen here? Say you have, as an example, say you have 4, and say you have 4 in hidden layer, 4 neurons. When every neuron is connected to every other neuron, how many connections will we have? You will have 4 into 4, 16 connections. Okay, you will have 16 connections. Then, if you have V, 172,000, say 10 hidden layer neurons, etc. If you have in that way, the number of connections will be V into H. V into H. But if you have n such words, for this word you will have VH, for this word you will have VH, for this word you will have VH, so NVH. Next, from this hidden layer to this hidden layer also there'll be connections. If you have H and here if you have H, H into H. In that way, if you have n words, n H into H, because here also you'll have HH. Here also you have H into H. Here also you'll have H into H. Here you'll have weights V into H. Here you'll have V into H, V into H. Here you'll have V into H. Here you'll have HH. So plus n into HH. Okay. Next. Now, if you have the output layer, of course, If you have 3 words, you want to predict the 4th word. If you have 4 words, you need to predict the 5th word in that way, right? If you have 3 words, you need to predict the next word. So the size of the output layer also will be V. And for each word, you'll get the probability. You pick that word which has the highest probability. And here the connection is VH. When you look at this, it will be N plus 1 into VH plus N into HH. These are the number of weights that we have. You might argue with me now saying that was for MLP, you had N plus 1 into VH, but for RNN, you're saying it's N plus 1 VH plus N HH. The number of weights are increasing. It's not a good model, you might argue. But then what happens here is, after you go in the forward pass, when you take a backward pass, so you're going forward and coming backward to update the weights, right? All these weights that you get here, VH, 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 you take an average of those weights and replace it with average. So in the next forward pass, all these weights will be the same. So even if you have N plus 1 into VH, what will happen? It becomes, N will become 1 because all of these will be the same. So it will become 2 VH plus. All these hidden layer weights, you take an average of those and you replace all of these with the average. So all of these weights will become same, constant. So 1 into HH, that will become HH. So you have 2 VH plus HH. So these are the number of weights. So now these weights are far less than these weights, right? N plus 1 into VH. And here, what are you doing? You're saying 2 VH plus HH. Obviously, 2 VH will be less than this. N minimum, you'll have 2 words. Hidden layers will be very less in comparison to vocabulary size. So problem solved. Memory issues, it's solved. Now, the issues which both of these models also had, traditional and MLP, were that the previous words were not getting stored in memory. But here, let's see what happens. This word will go and give an input to this. So this word also is getting carried forward. And then the second word also will go. Now, these 2 words are moving forward. Okay. And here, when the third word is applied, the previous 2 words and this word. So all the words are getting carried forward. So the previous words are stored in memory. Okay. So words are stored in memory. This issue is also solved. The next issue is fixed window problem, which MLP had. That means if you have 3 words, it will predict the 4th word. That's it. That is all that model can do. If you have 2 words and predict the 3rd word, or if you have 4 words and predict the 5th word, it doesn't work. What do we do in that scenario? Okay, in that scenario, we do something else. What is that something else? That something else is when it comes to RNN, if you have 3 words, this network will expand 3 times. If you have 4 words, it will expand 4 times. If you have 5 words, it will expand 5 times. If you have 6 words, it will expand 6 times. If you have only 2 words, it will collapse. So the network will automatically expand and the network will automatically collapse. So that fixed window problem is also solved. So RNN can work for multiple window width. That's the problem. That's what we have to do. Okay. So recurrent neural network hence will solve all the problems. So now we need to take a break. But before we take a break, a few quick things. We will be posting feedback form now, not attendance, but feedback form. And please provide your feedback. There are two ways of giving feedback. One is the feedback form. We'll collect it and we'll analyze it for our betterment. Second thing is, I request you all to also provide us Google reviews. And the link pertaining to this would also be shared with you all. Okay, these are the two things that I request you all to do while we take a break. And what's the time now? It's almost 3 p.m. Let us connect back by 3:15 p.m. And I request everyone to please ensure that you fill the feedback form meanwhile and also provide the Google review. Thank you. After the break, we'll connect. Thank you. And also, we shall share with you all the certificates, how to process the certificates, etc. We'll communicate on the WhatsApp group. Certificates will be processed, but we'll communicate. Thank you. Yep, hello. So, are you done? Can you all please confirm whether you have completed giving the feedback as well as giving the review? Please, can you use the chat window to quickly confirm? Okay. So I'm hoping that you're filling that, which is very much needed. Your feedback as well as the review, I request you all to please provide, and then we'll proceed. All right, friends. So let's continue. And there are a couple of things that we are expected to help you with. One is with respect to the end-to-end deployment part. So we will resort to MLP or artificial neural network. And then we are going to show you the deployment part. For this, I would request our team member, Aditya, to share the screen. Aditya, would you please share your screen? And while you share your screen, I am going to explain from my side. Yeah, please go ahead and share your screen.
Yes, Bharani. Just 1 minute, please.
All right. In the meanwhile, if you have any questions, feel free to ask me. Okay, wonderful. So friends, remember when it came to our artificial neural network, we have built the model and we have just done the predictions. But for all practical reasons, you don't share the code with your customer. Instead, we provide them an interface, like a web interface, in which they can supply the new data, and then you'll get the predictions. And for this, we want to show you the actual code, and we want to show you how we have saved the model on the computer. Okay, and then we'll quickly walk you guys through this. So Aditya, would you mind showing on how to save the model? Okay, so until line number 88, we've already run the model. Right? When it comes to line number 90, the model that we have built, we are saving it onto our computer, and we are saving it using the name model1.h5. Line number 90, if the mouse cursor can be hovered on that, you'll see the results. Right? And how to load the model, how to predict on the new data is given here, but that's not an area of interest for us. Our area of interest is that we saved the model that we built. Now, this model that we saved should be deployed in the production. Okay, now let's deploy this in production. How do we deploy? This is how you deploy. For deployment purpose, we have something called as Python Flask. Flask application works very well, at least from the proof of concept standpoint. Okay. And if you look at line number 9, we are from Flask importing Flask, and there are certain HTML templates which we are importing. And if you look at line number 17, we are loading the model, model1.h5, you are loading that. And post loading, if you look at line number 26, We are reading the new file, which only has the inputs. And then output should be predicted. You only take the inputs. And then if you look at 97, you're reading that CSV file. Line number 28, you're doing the pre-processing, converting the data into float format. Line number 30, you're normalizing the data. Line number 32, with the loaded model, you're predicting on the data. Then we have line number 39, which has evaluating the score. Okay, this is what we are doing. Now, if we want to run this Python file, we need to go to the terminal. Yep. Can we launch the terminal? The terminal that you're seeing here is basically, what do I call this? This is a Linux interface. So I would request Aditya that we are teaching it on Windows, right? So do one thing, share with me the model file, the app.py, the Flask file, and the new CSV file with the test data. You share all those three. I would actually put it onto my system and then run it. I'll do that also. But before you do that, can you just run the code? This we are showing in Linux environment. Okay, wherever you have that app.py file saved, you need to move your directory to that. And then you just type Python space the name of that file. If you have named the file as app, then it'll be app.py. Yeah, please run it. Don't worry about those errors. You would not get those errors anyways. Okay. So there is a specific path, which is 127.0.0.1. That's called as a localhost IP address. And the port number, there is something called as port number on which Flask will run. When you supply new data to your computer, that new data should be given to Flask using some port number. That's like gate number. When you want to get into airport, you'll have a boarding pass and you need to enter from some gate number. This is like that gate number. From that gate, you will have to enter. Yep. Go ahead, please. This is the kind of interface that you guys would see. Okay, so that Flask code that you have seen, app.py, this is how it would show you the details. Now, this is the kind of interface that we are going to give to our end users, to our end customers. Can you please click on choose file? Yeah. Now, when you click on submit, you get to see the result. So we have given only one record. All those are your, probabilities, right? And if you see, you have 0, 1, 2, 3, all those are you have to hover your mouse on wherever I'm talking, whichever part I'm talking about, so that it's clear for everyone. So 0, 1, 2, 3, 4, 5, etc. are your digits, handwritten digits. The pixel values of those are being supplied as input. And your model is classifying that this digit will be 0, which is in the first column. So in the first column, do you see 0? 0 means your model is predicting that it's 0. And also, if you see, there are probability values corresponding in each and every column. 0.984818 is actually the probability that the new entry that you have supplied is a digit, is 0. In that way, you have all the values which are given. Okay, so that's how things work, friends. So this marks the end of the deployment part. Now I would like to share my screen. And while I share my screen, our Aditya would also share the details with me of app.py, then the model file.hdf5. That's the format in which you save the model. And he will also share with me the Excel sheet or CSV file with the test data, and then I'll explain in detail, further detail. While I do that, we will, in the interim, run the RNN code. Okay, we have recurrent neural network code. We will have to run that. And once we run the RNN code, I'll get back to this deployment part and we will mark the closure. So I'm getting to the RNN file. Okay, so just give me a moment while I try to take this up. There is a specific code for RNN. I wish to open that and run it for you guys. So done. I got access to the code. I am going to open Google Colab so that you do not get confused. If you have some issues, right, GPUs, etc., you'll not be able to run that if you do not have GPUs. So I would always recommend to open Google Colab. So all you need to do is just go to internet and type Google Colab, go to the browser and click on that. And this opens up. You can say new notepad is what you are interested in. A new notepad opens up. Okay. And you can also rename that as rnn.ipython. Then I'm just getting the code here. And I'm not going to confuse you with too much of stuff, but certainly I would like to explain certain most important aspects. And then, yep. So let me run this code and help you all understand. Post that also the deployment part will be explained. So we need to load the most important libraries. As I've told you, TensorFlow, Keras, right, are now combined kind of. Right? Keras is very much part of TensorFlow. Okay, and before we run it, we'll go to runtime. We'll change the runtime type and we'll proceed further with GPU machine. I'm going to save it. So we are importing simple RNN, sequential model, embeddings, so on and so forth. Embeddings means every word that you have, when you supply your textual data, the text, to your RNN, if you supply in the raw format, it will throw you errors. So what should you do? You need to convert the text into some numbers, some numeric format. Okay, converting your text into numeric format is done using embedding. And only then you supply the numbers to your recurrent neural network. So we have the embedding, simple neural network, anyways, that we have loaded it here. And we are taking internet movie database. IMDb is a database where people write reviews about all the movies. A few people might write positive reviews. A few people might write negative reviews. So we are building a model here to predict whether a review is positive or negative. That's called a sentiment analysis. So here, ultimately, we are doing sentiment analysis. So we are also saying maximum features equal to 10,000, maximum length equal to 500, batch size is equal to 32. Okay. What do you mean by maximum features is equal to 10,000? Suppose you have some 50,000 reviews, movie reviews. In all these movie reviews, you'll have different words. Say you got, out of all these reviews, you got 100,000 words. So these are the number of reviews, movie reviews. And say these are the number of words. Okay. Now, these words would be sorted. For example, you have a word called amazing. You have a word called wonderful. You have a word called disaster. So in that way, say there are multiple words. Okay, so 1, 2, 3, 4. In that way, say you have 100,000 words. You look at how many times each word appeared. So the count. You have the words. Okay, and you also have the count on how many times each word appeared. Then you sort them in descending order, decreasing order. And then you're saying that I want to take only the top 10,000 words. Remaining 90,000 words, you want to say remove. That's called as maximum features is 10,000. So the number of words is equal to maximum features, that is 10,000. You're saying I want only top 10,000 words, which have been used maximum times. And you're saying imdb.load data, and you're loading this data into inputs and output of training data, inputs and output of test data. Then you can look at how many, training data inputs you have, how many training data, test data entries do you have, rows, right? So on and so forth. Then you can look at the shape. How many rows, how many columns do we have for the data, etc. So let me first run that. Whichever are trivial stuff, I don't intend to, give it in a big way. This I can remove. Run it. So wherever you have a print given, that would come up on the screen. So now what's happening is a server is getting allocated to you from Google, free version. So the data is loaded. It took probably just 1 second to load the data. Then So you have print, appears. Then when you say print, the length of input data, you have 25,000 movie reviews in the training data. Then we have another 25,000 in test data. When you look at the shape of the input data, you have 25,000 and 500. That means every review, from every review, you're taking only 500 words. So you might have review 1, review 2, review 3 in that way, multiple movie reviews. One review might be for exactly 500 words. Another review might be only for 10 words. Another review might be 1,000 words. So you cut down all the reviews to 500. That's your cutoff. You'll ensure that all the reviews are cut at 500. Okay. And whichever review has less number of words, what you do is you do something called as padding. You do something called as padding. What do you mean by padding? Padding means you add zeros. You have only 10 words, but you're saying you want 500 words. That's the limit. So what you're doing is until you get 500, you put zeros. That's how you do. Okay. You also have the test data. So you have test data and training. Okay. Now you're importing dense. Dense means fully connected network. If every neuron is connected to every other neuron, it's called as a dense network, right? So, for example, if you have a network like this, if every neuron is connected to every other neuron, in that way, then it's called as what? Dense network. So we're importing dense. We have a sequential model. Okay. And why are we using embedding? Because when you have words, textual data, okay, and when you want to supply this textual data to your network, you need to convert the textual data into numbers. Embedding will actually convert the textual data into numbers. Okay. And you're saying that each word should be represented using 32 numbers. So just take as an example, friends, on what happens if you do one hot encoding. Or let me put it this way. If you have your textual data, you need to first convert this into numbers. Converting the text into numbers is called as vectorization. And then to perform this, you have one hot encoding format. And also we have embedding. If you have a specific word called amazing, for example, what usually happens? How many of the words you have in your data set, unique words? You take all those unique words. Say there are 20,000 unique words. Okay, take all those unique words. Wherever it's not amazing, put 0. Wherever you have the word amazing, put 1. Rest all will be zeros. This is called as one hot encoding. And there is another way which is called as embedding. What do you mean by embedding? rather than have such lengthy set of numbers, you're going to say that every word I want to represent using 32 bits, 32 numbers. So amazing will have a unique number, which will be of 32 bit. It will be some number, 1, 2, 3, or 6, 7, 8, or 8, 1, 2, some number, which will uniquely identify this word. Okay. Next, you're saying that I want a sequential model wherein the words, the maximum features, which are, I think, 1,000 or 10,000, whatever we've given here. How much should we give? 10,000. So you're saying take maximum 10,000 words and convert every word into an embedding, and then connect that to simple RNN, simple recurrent neural network. And this recurrent neural network will have 32 neurons. Okay. And then, of course, the first hidden layer will be a dummy layer in recurrent neural network. So you have the embeddings, you supply them, and here you have, say, 32 neurons. And this would be connected to a single neuron, which is sigmoid. Why single neuron? Because the prediction here is a specific movie review going to be positive or negative for that purpose? And if you, this is binary classification problem. Whenever you have a two-class classification problem or binary classification problem, in the output layer neuron, we have sigmoid activation function. Then what are we doing? So this is your designing the network. Then you're compiling the network. In compilation, you need to provide the optimizer details. Here we are saying RMS root mean squared propagated. And then you're also providing loss, which is binary cross entropy. And you're giving a metric, which is accuracy. Okay, metric, accuracy, loss, binary cross entropy, this. And you're compiling the model. And then you're fitting the model. When you fit the model, you're giving inputs and output. And you're supplying, you're saying you want 10 epochs. Okay. And then you're giving a batch size of 128. Validation split is 20%. So what you're doing is, from your training data itself, you're saying take 20% and keep it aside as validation randomly. And then I run it. So you design the network, compile the network, and fit the model. Epochs are starting to run. This is epoch 1. So it's taking a while. Usually, yes, that's what happens. And while that happens, let me download the data, which is given to me by Aditya. I'm sure he would have sent me email by now. Yes. So let this run and we will continue. So epoch number 3 is running now. And roughly it is taking 1 minute per epoch, right? So that's the amount of time that it is consuming on a GPU machine. Now just imagine running this on a CPU machine. How much time would that take? Right? You have to think about that. While that happens, I also wish to show you the model part, right? So let me switch the gears and explain this in the interim. So friends, to deploy Flask, so whenever you build a model, right, especially if it's a deep learning model, neural network model, you save that using .h5 or using .htf file format. And here we are saving that as .h5 format. Okay. And then whatever code you have written from Flask standpoint, you're storing it using a name called app.py. Within templates, you'll have HTML template. Majority of them will be readily available on internet also. You can just take, place it. And then we have a file called test.csv. Which has data of one image. One image, you have all these pixel values, right? That's what you have taken. 784 pixel values will be there. Okay. Then you have requirements.txt. What are the various libraries that you're using? What are the versions of those libraries? That is very important. Okay. Once you have a model of this kind, you just copy the path. Okay, let me first unzip this. Extract all to this location. So this is the path, right, in which you have the files. So I'll go to this path, copy that, and go to your Anaconda. And here I'll go to environment. And click on open terminal. When you click on open terminal, you get the terminal in which you need to change the directory. You have to say change directory. And you give the path where you have those files. Then enter. Then the directory changes to a different path. Then you have to say Python app.py. That means you want to run this Flask application. But then it's saying no module named TensorFlow. The reason being TensorFlow is not installed. Okay, so I can always go here, say open terminal. Okay, and we can always install Why am I using Conda? Because this is Anaconda, right? In that I'm installing. You can always say, let me install TensorFlow, the GPU version, because I have GPUs. How do I figure out whether I have GPUs or not? Just press Control Alt Delete on your keyboard. Then you'll get to Task Manager. Okay. Then here, if I go to the section Performance, do you see GPU here? NVIDIA GPU. Yes, this is a GPU that we have, NVIDIA GTX 1660 Ti. 1660 Ti is a very small configuration pertaining to GPU, but still something is better than nothing. So we have that. So I'll let this unpack and do all these installation. It will take huge amount of time, no doubt. But ideally what happens is when you run this, it will give you a URL, the way it has done on our friend Aditya's computer. That URL, when you type, the same interface will come. You supply the CSV or this new sheet, CSV file, and then it will give you the output. That is how it works. So it's taking a while. If you see here, it's not going to be very simple installation. It will install a lot of things. That's okay. Let it take its own sweet time. Anyways, we have seen that. Okay. So now I'll go to recurrent neural network. And here, yes, every epoch is taking approximately 65 seconds or so. That's approximately a minute. And we are in the 8th epoch. After 8th epoch, there will be 2 more epochs, and that would conclude the model running. After that, I'll just show you how to evaluate the model, and that marks the end of the training. So let it go on. I'll just wait for, we will have to wait for rather 2 more minutes. All right, so we are done, right? We are done with this. Now, let me, let me tell you that we can also evaluate whether our model is good, bad, etc., which we shall do it. If you may allow me a quick minute, I'm going to show you the final part. And There we go. So here, friends, for every epoch, you see loss, right? So, and where are you saving your model in? History. You're creating an object called history. When you say history dot history, even if you give ABC here, ABC dot history, right, would capture the history of all these accuracies, which are training accuracy values. You're storing it in this. Then you also have validation accuracy values. You're storing it in this history dot history of this. Then you also have loss. You can store that. Validation loss also, you can store that. But I think we will not use that validation, or we will not use a loss. So I'll remove that. Then we are taking epochs. We are saying range should be 1 until length of accuracy plus 1. So if you run 10 epochs, you have 10 accuracies, plus 1 will give you 11. Hey, why are you taking 11? When you say range of 1, 11, because length of accuracy will give you 10, because you have 10 accuracy values, plus 1. This would give you numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The last value is ignored in Python. Hence, you're giving plus 1. Now you're plotting. So from matplotlib, you're taking PLT. When you say plt.plot, you're giving epochs on x-axis and accuracy values on y-axis. And then you're going to, you're taking blue color circles and giving a label called training accuracy. On that only, on top of that, you're saying I want another plot where x-axis will be same epochs, but on y-axis you want validation accuracy, that too in blue color line. Label should be validation accuracy. Overall title would be training and validation accuracy. Overall title. And you want a legend. Legend means which is training accuracy, which is validation accuracy, and you want to see the plot. So let me run it. There we go. So when you say legend, this would come up. You want a title? Yep, we have a title. And here we have epochs, the 10 epochs, and we have the accuracy values, which are in blue color circles, which are nothing but training accuracy values. And the legend is given. You also want to plot epochs and validation accuracy. Whichever point where both your training and validation accuracies are high, you stop there. Because increasing the number of epochs from there on would just diverge, right? It's diverging like that. That means your training accuracy will continue to increase, but your validation accuracy will continue to decrease. And this is how you run the model. So just to give you a quick idea on what all we have covered, we understood CRISP MLQ project management methodology. We have done deep learning primer, math foundations, deep learning challenges and practical issues. Then we have looked at artificial neural network, which is multi-layered perceptron. Then we looked at convolutional neural networks, which deals with images. Then now we have dealt with RNN, which deals with textual data. We also have bidirectional RNN, deep bidirectional RNNs. Then we have advanced versions of these called as LSTM, long short-term memory, bidirectional LSTM, deep bidirectional LSTMs. You also have GRUs, gated recurrent units, bidirectional GRUs, deep bidirectional GRUs. Then you have transformers. Wherein you have BERT models, which is from Google. Then you have GPT models, which is from a company called as OpenAI. Then you have OPT models, which are from Facebook. These are all very, very advanced techniques. And these techniques are giving amazing results. Okay, so these are the various things that you might want to explore moving further. Then we have generative adversarial networks. Then you have autoencoders, and you have reinforcement learnings. These are also a few aspects which you might want to focus upon. Okay, so while I'm going to stop here, and we will also stop the live session, I once again request you all to provide the feedback, whoever has not provided the feedback. And today, feedback would be considered as the attendance. Okay, so please fill the feedback forms. So today the attendance will be tracked using the feedback form. And a humble request is please leave the Google review also. And the link is shared here so that it helps us grow further alongside you also. And there are a lot of other sessions which we are planning up. And one such section is, friends, let me go to YouTube here. And let me go to 360. Here we have this data analytics using Excel in the evening from 6:30 to 7:30 every day for 15 days. 2-day session is done, 3rd day session is there. But to be notified about these kind of things, you just need to subscribe to the channel and click on this bell icon so that you receive the future details. Here is the, but you should be logged into your Gmail. If you are in your Gmail account, then only you can give review, then only you can subscribe. This is all that I had to say for today. And I think it has been an amazing journey, and you have been super cool to interact with me. Basically, just a minute. Okay, so we will be posting the feedback link, and feedback link would be treated as attendance also, and also the Google review. So once again, I would from my side also share the feedback form. So the feedback form would be treated as attendance also. And here is a Google review link. I request you all to please provide the review. Thank you once again, and have a great day. And if you have any questions moving forward, you just